All right, welcome to another week. Now that we've done some background context learning of the alternator or charging system itself and the components involved, this week we are going to focus now on the charging system again, but more with the diagnosis and repair of the components. And it's important because last week we started to understand what these different components do, how this AC electric is rectified, and now we can start to understand where some of the problems are. We want to focus this week on our troubleshooting procedures. And I can tell you there's nothing like having a consistent method of troubleshooting a problem, doing the same test over and over and over on every vehicle and doing it in a sequence that gives us results that tell us what's actually going on. We're going to look at the outputs of the charging system with our volt ohm meters that we've looked at. We'll also talk about load testing, which has kind of gone to the wayside on our newer vehicles where we're actually using conductance testing. We're going to carry out these procedures on removing and replacing the alternator. We're going to talk about procedures that are related to servicing that alternator. We also want to know about procedures that possibly would be related to rebuilding alternators. Even though today it's very difficult to find the components to rebuild, we still want to understand the process. We want to understand charging problem symptoms such as a dead battery, an overcharged battery, abnormal noises, and then indicators that are showing us. Particularly important with our newer vehicles that have battery management systems on there, controlling the amount of charge, determining when to field that alternator, whether it's at idle, under hard acceleration, or deceleration, and really trying to get the most efficient, possible methods obtained for our vehicles to go down the road, and ultimately, save us on that gas price, especially with the prices of them right now at the pump. So much like diagnosing any system on an automobile, the very first thing we want to focus on is a visual inspection. A visual inspection of those components that are related to the system would be the priority in this case. So the first thing we want to do is take a look at that battery, right? Check for those loose cable fittings, maybe run a Midtronics test on the vehicle, a capacitance check on the battery, see if it's discharged. If it is discharged, does it need to be charged up? Will the battery accept a charge? A lot of variables there to take a look at that could be just related to the battery itself. We also want to take a look for corrosion on terminals that'll create high resistance, low water level on those maintenance style batteries. Today, most batteries say are maintenance free. And then we want to look at the case. Look at that case and see if the actual battery case itself looks like it's swollen or bloated, which in many cases indicates that something internally is going bad with the battery or overcharging might be happening. Additionally, we want to look at the alternator and wiring problems, right? So see if the alternator problems are related to a loose belt. Maybe the belt's been broken and fallen off completely. This happens quite a bit. People don't even realize that the belt that runs or drives the alternator may have just come off, may have broken. We want to look at wiring problems, loose or shorted wires, and also corroded connections here. Also keep in mind that sometimes rodents will get in the vehicle, and for some reason they tend to like the insulation of wiring, and if they chew through any of that material, you want to look for signs of maybe rodent nest or something that might be underneath there. I know that doesn't sound pleasant, but the reality of it is that sometimes vehicles will indeed attract these critters and cause some problems. So again, we're doing an overall visual inspection. We're looking for any types of hint or clues as to what might be going on with that charging system itself. The next thing that we want to do is be aware of some of the precautions that are involved in this. When we're disconnecting battery cables and connecting chargers, we want to be careful of any gassing that might have occurred. Typically, we want to connect that negative battery cable away from the battery somewhere when we're charging it. We don't want to reverse the polarity. We want to make sure that we're indeed hooking up the positive cable to the positive terminal of the battery. We also want to look at The alternator. We don't want to run that alternator with everything disconnected because you'll have no place for that electricity to go. We don't want to run it freewheeling. You don't want to have the terminals grounded unless you're instructed to do so. We don't want to ground any of those terminals because we could be creating a direct short. We could burn out some of the electrical components. And by all means, we want to be using caution with our safety glasses, making sure our jewelry's off, and looking at anything, especially being mindful of a running engine. When we're now looking at the charging system tests that are available, the first thing we're going to do is the battery test that we'd be most interested in. Make sure that battery, our source voltage, is always good. That's a number one rule. Once we're done with that, and we make sure that the battery indeed either is good or needs to be replaced, then we can adequately start to look at charging system output test and determine other areas such as the regulator for the voltage test. Is the voltage stable where it's supposed to be? Is it able to compensate for any loads that are added to the system? Is the circuit resistance that is available, is it within the specification, meaning that between the wires, do we have excessive resistance? Sometimes we'll see corrosion build up internally on some of these wires, and that corrosion adds additional resistance to the wire that should have very little resistance involved. The next area that we want to take a look at are our voltmeter test, right? And our voltmeter is pretty much going to focus on our base voltage, seeing where that battery's sitting at normally, looking at the no load voltage, and then looking at the loaded voltage. And how would we potentially add a load? It could be as simple as just turning on the headlights for the vehicle, right? Without having to get any special tools and seeing how that battery responds. We're looking at the behavior to make sure that when we put a stress on this battery, that it can indeed hold that load. Now, we don't want to see it dropping too low, because if it is, that means the battery, while it may show 12 volts, it can't hold any actual stress when it's loaded. To measure that base voltage, we're going to connect the meter probes across the battery terminals. Fairly simple. We'll put the positive terminal from the battery on the positive feed of our wire, usually indicated by red, but Testing the regulator voltage is done by checking for calibration of what they call the voltage regulator. This detects high or low voltage settings, and the test procedure for this is to set the meter to the test position, turn the load off, and run the engine at the specified RPM, and read the meter and compare these specs. Now, this is typically done with the VAT40 on older alternator styles that check for this high and low setting of the voltage regulator. On the newer style Midtronics tester, this is done internally through the circuitry in that Midtronics unit. So this regulator's voltage tester is actually checked to see what it would do under a different load and see if it actually reacts the way that it's supposed to. Here you can see the basic charts, whether that voltage reading that we get for the regulator is steady and within the specification for the vehicle. If it was steady but it was too high or too low, that may indicate a problem with the regulator determining where the voltage is supposed to be. And if it's not steady, that's usually an indication of a problem with the wiring, alternator, or regulator. It could be any one of those. Typically we usually see diodes that start going out when we see these irregularities. Circuit resistance tests are done pretty much the same way we always do resistance checks. We're going to locate the wiring problem, and we're going to do this by trying to locate loose connections, corroded terminals, or partially burned wires. Sometimes just the simple feel of the wire, they will feel hard when they start to burn. And we're going to sit there and look and run when the symptoms indicate there's problems other than the alternator or regulator. So if we see something that maybe is, hey, the alternator is operating indeed the way it's supposed to, it's responding to the voltage changes and the loads and so forth, we may want to go and check the actual wiring that's going to the unit and see if something may have happened that's caused it to get burned or have excessive resistance in that line. For the resistance test, as you've been trained, you might remember that voltage drop testing is the best method to do this. And so to check the positive side of this, we would check from the positive terminal of the battery to the positive lead of the alternator to determine what the voltage drop is across that wire. And if we had excessive voltage drop there, we typically would want to replace that wire. That spec can usually be found in your service information. Now, on the other side, we need to deal with the ground side of this, and that's done the same way. Again, we're going to set our meter to voltage. We're going to go between the housing where it grounds to the engine and the negative terminal of the battery to see if we have excessive voltage drop. Now, again, each manufacturer will be different in this number, but typically anything more than about 0.2 of a volt is considered excessive voltage drop on these heavy lines. In cases where we're looking to do alternator service, we typically know this because we have low voltage or current output that's indicate a bad alternator. No matter what we do, we can't get this alternator to put out voltage. So we got 12 volts to it, and when we're fielding it, it's not giving out any increase in voltage or current. We're really stuck with two options. We could repair or replace, and the most common option today is to replace the alternator, simply because it's just not cost effective when you figure out what the labor time would be to go in and internally repair all the components. Plus, the rebuilt units typically come with their own factory warranty. Removing the alternator usually involves some basic steps, but probably the most critical is to disconnect the battery. And this can be done by simply taking off the negative battery terminal. And this isolates things just in case that hot wire touches ground. And trust me, if you don't do it, it'll happen. So usually what you want to do, very first step, whenever we're going to do something on an electrical component, we're going to remove something, especially with the size of the wires, disconnect that negative cable. Then we're going to loosen all the bolts. Right, we're going to loosen them all up just a little bit, not take them out, just loosen them. Then we'll be able to take the slack or the tension off of the belt so that we can get the alternator belt off of the vehicle. And then we'll remove the alternator, and we want to make particular notes about where the wires and washers are located. Typically, I really recommend trying to use a phone, since most people today are carrying some kind of cell phone that can capture pictures, and the pictures will save you a ton of time. Next, on the disassembly, we'll probably want to put this up on some kind of vise. So we want to scribe marks on the housing, some kind of line, so that we know how this goes back together. We'll remove the alternator through bolts, and then we'll slide the end frame from the rotor shaft, and then we'll remove the remaining parts, or the internal parts of this alternator. In order to check the stator of this unit, we want to use our ohm meter, and we're going to inspect for signs of burning. And what we're really looking to do is test for opens or grounded windings. Are they shorted together, and is there excessive resistance between those windings on this unit? Believe it or not, this is the same exact test that we do on larger motor generators that are found in hybrid vehicles. This is a three-phase unit. It's a smaller unit, but the principles are the same. So we'll set our meter to ohms, and then we'll actually check between the pairs, and then we'll also check between the actual windings themselves to see if we have any opens or anything that's grounded together. Sometimes the insulation around those windings will actually wear off, and then that shorts the wires together. Remember also to check the slip ring contacts on the rotor windings for a short to ground test. And if you test between these two units on those slip rings, you should have an infinity reading on your ohm meter, indicating that there is no continuity between these parts and the actual ground portion of the shaft. Here's another image of a procedure that you could use, and again, we would be doing the rotor winding open test here. So when you actually touch these two parts, what would you expect to see? That's correct. You should see continuity here, just not with the ground shaft. If you didn't, then that would mean that we have some kind of open in that rotor winding. Now, keep in mind there's another test, which is the rotor current test. And in this case, you could carefully run power to each of those slip ring contacts from a battery, positive and negative. And you don't necessarily have to run it through the meter. We could use an amp clamp. But what we're looking for is to see what the current being drawn through that field winding is. Typically a decent reading is around 3 amps in this case. Now, the alternator diode service typically is one that requires a certain set of tools. You need that ohm meter, maybe a test light, sometimes an oscilloscope, and very often a diode tester. Most of the reasons that this isn't done anymore is because in most cases it requires that we have to unsolder the diodes for some of these tests, and it just becomes too time consuming to make it practical or effective for a technician before we just replace it. But if we were doing this, we would want to remove the diode assembly from the alternator, and we're going to unsolder those diodes, usually using a soldering gun. And then we'll take a meter reading in both directions. What we're looking for is open or shorted diodes. Now, some meters will have a diode tester, in which case when you put it one way it'll beep at you, the other way it shouldn't. And this is indicating that the flow can go in one direction and is working. Sometimes you'll hear this term leaking diode, and that's what they're referring to. The diode trio itself, right, though, we can use an ohm meter here, and we can just simply check between the single connector and then the 3 different connectors. And this is found a little bit on more of the modern vehicles, although most newer vehicles today will include this all in one housing for the voltage regulator. Now, bearings for alternators will sometimes go bad, especially if we're going to rebuild it. We'd want to replace these. If you're going to do a service, you'd replace the bearings. And those are the drive-in bearings and the diode bearing that's part of the slip ring on the back. And if they're not replaced, you want to at least try to grease these a little bit. They're done the same way as most bearings. They're kind of knocked out with some kind of press, and then you're tapping them back in to position. Not a whole lot of science there. The alternator brush service, though, is a far different story. These brushes can be inspected, and very often you'll find that these are part of the reason that they've met their service limit. They've pressed out far enough, and it's maybe the reason that you're not getting voltage out of the system. And alternator brushes can be replaced fairly easy. There's a measurement for the length of these brushes, and then you replace them if they're worn or soaked with oil or grease. Very often, though, it's pretty easy to determine that these are not pressing out far enough on the alternator slip rings. When you take it off, these things should be pushing that little box, the alternator brush box, off of the top because of the spring tension that's there. Now, once you've got that thing all apart, if you wanted to put it back together, we're pretty much just going to reverse the order of our disassembly. And you always want to reference a service manual, the service literature on this process, if it contains it anymore. Again, you'll find this on older vehicles. Many of the newer vehicles, they don't offer this type of information anymore. But you'll want to install that regulator, the diode pack, your bearings if you've replaced them, or if not, you're going to add that grease. And then we want to make sure our terminals and nuts in the rear are put in. We'll install a new set of brushes in most cases. We'll install a spacer that pushes the fan a little way so it's not bound right up against the front of the housing, the front pulley, depending on the unit that it has, and then the lock washer and nut. We're going to check to make sure by hand that the rotor movement's nice and smooth, and then we'll torque that pulley nut to the spec. And then if we want, what we can do is put it on a bench tester and run it before we even go to install it in the car and verify that it's outputting voltage for us. Now, installing the brushes, you can see here, we're going to push those in, and usually what will happen is there's a lock that you can stick a small, some kind of piece of wire or thicker than wire through there to lock the brushes in. Most often when you're replacing these, they come with that lock installed, and then you put in the brush pack and then you pull out it, which allows the two brushes to slip forward and press up against the slip rings on here, which would be critical. And then keep in mind that often those carbon brushes, they may not be perfectly round with the slip rings, and it takes a little bit of driving to kind of wear them in so that you get a nice smooth contact of the complete service. Now, one really important thing to try to make sure is that we get that spacer washer in behind the pulley nut. I can't tell you how many times this has been forgotten or put in the wrong order on the outside of the pulley. And then what happens is you'll have a completely seized up alternator. If you don't check it before you put it on, you can fire a car up, have a fan housing that's stuck and a belt that's squealing and often smoking away because it can't rotate that portion of the alternator. So again, just to make sure you get that washer in there. And on the installation, we want to connect wires first that are necessary. We want to fit that alternator onto the front of the engine and hand start all of our bolts. We don't want to tighten down anything yet because that may cause misalignment of the other bolts. Then we're going to put the alternator belt back on, and we want to check that and we want to install it, right? We either want to replace that belt, or if we're reusing it, we put it on after we've inspected it for, cracks and so forth, and we're going to tighten it up. And then and only then, once all the wires are connected, now we're going to reconnect our battery terminal and allow voltage to now flow in the car as it should. Then as far as the regulator service, regulators can't be repaired. Most of the circuitry that's going on inside them just can't be done. Some can be adjusted so that the contact point regulator styles have an adjustment in there. And that's only on some regulators that you'd see that are very old. But for the most part today, the voltage regulator itself is a replaceable unit as one. And this is actually a very good cost savings measure for most alternators, since this seems to be one of the higher failure points on a vehicle. Here you can see a picture of how you might test a voltage regulator using the two prongs. We would power those sides and then figure out the negative side. And then from there we'd want to put a battery charger on there and see that we could actually put different loads on it. There's an internal voltage regulation that occurs inside of it. But again, this is old technology. If you see one, it would probably be pre-80s to see something like this. And then again, on those older units, on the late model vehicles, these are part of service manuals, and you have to find the service manual in most cases. And then they have contact points that are adjusted, much like points are on a distributor cap. But if the regulator can't be adjusted, then you simply replace it. And in most cases, things that old at this point probably would need replacement because just of the age. All right, and that's about it. So if you have any questions, please feel free to ask and let me know so that I can address any specifics on here. We'll also be going over this a bit in class this week to just kind of further develop your thoughts in the process of diagnosing these.